Welcome. Let's discuss the remainder theorem. In example 1, we want to know, is the expression x minus 1 a factor of 3x squared minus x minus 2? If we want to use the remainder theorem, what we can do, we can evaluate the expression of 3x squared minus x minus 2 by the value that we can obtain when we look at the possible factor and we set it equal to 0, which in this case, it is a value of 1. So let's do that. And then we're going to get 3 times 1 to the second minus 1 minus 2. Our first expression here, it is equivalent to just 3 minus 1 minus 2. Then we're going to get 3 minus 3, and then we're going to get a value of 0. Now let's make sense of our result. Because after this evaluation, we obtain a value of 0, then we can say that x minus 1 is a factor of the expression that we tested on, 3x squared minus x minus 2. So notice that this gave us the result that we would obtain from a division, but way faster. We can think of this as a shortcut. And it's even more into detail. This value of 0 is the actual remainder. If we would have performed the division of 3x squared minus x minus 2 divided by x minus 1. The only type of questions that we can answer is, do we have a factor? And the reason why we can do that is because we can obtain the remainder faster. Let's take a look at example B. So here we have the same type of question. It's x minus 2 a factor of this whole expression? Well, we can do long division or synthetic division and look for the remainder. But instead of doing that, let's get the expression of 3x to the third plus x squared minus 4x minus 1. And then let's evaluate it by the result that we would obtain if we set the possible factor equals to 0, which in this case, it will be of a value of 2. And by doing this, we're going to obtain the remainder way faster than long division or synthetic division. So let's do that. We are going to get 3 times 2 raised to the third plus 2 raised to the second minus 4 times 2 minus 1. All we are doing is every time we see a value of x, we are substituting it with the value of x equals 2. So now let's evaluate this. So here we have 3 times 8 plus 4 minus 8 minus 1. And 3 times 8, that's 24. So we'll get 24 plus 4 minus 8 minus 1. And when we combine all this, we obtain a value of 19. Well, let's make sense of this result. Here we are saying that if we would have performed the division of 3x to the third plus x squared minus 4x minus 1 divided by x minus 2, we would have obtained a remainder of a value of 19. Notice that this remainder, it's not of a value of 0. Then we can say that the expression of x minus 2 is not a factor of the expression 3x to the cube plus x squared minus 4x minus 1. Let's take a look at our last example. So here we have the same situation. Is the expression x plus 2 a factor of 3x cubed plus x squared minus 5x plus 3? Let's use the remainder theorem. Let's get the possible factor and solve for x, which is going to give me -2. And what we will do, we're going to evaluate the expression by -2. Well, let's do that. And now let's just evaluate this. -2 to the third, that is 8. -2 to the second, that is +4. -5 times -2, that is 10. And then +3. 8 and 3, that's 24. And when we combine all this, it is equivalent to 41. So what we are saying is this. If we were to obtain the division of 3x to the third plus x squared minus 5x plus 3, and we would divide it by x plus 2, then we would obtain a remainder of 41. Then we can say that because the remainder is not 0, then we can say that the expression x plus 2 is not a factor of the expression 3x cubed plus x squared minus 5x plus 3. So we are done. But before we wrap up this idea, there's one more thing that I would like to mention. If we want to use the remainder theorem, we have to make sure that the factor are in the form of x minus some number or x plus some number. So let's illustrate this real quick. So let's say that we have some problem that says, is x plus 1 a factor of x to the third plus x squared plus 3x minus 5? In here, notice that the highest degree is 1. Then we can perform the remainder theorem. But if we switch this up and we ask the question, is x squared plus 1 a factor of x to the third plus x squared plus 3x minus 5? Then unfortunately, because the highest degree, it's not 1, then we cannot perform the remainder theorem. In this case, we need to do either long division, and that's it. So we have to be careful with that. The remainder theorem, it's a very specific case. The highest degree, it needs to be of a value of 1. So let's keep this in mind when we are considering the remainder theorem. Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.